The county told him 5 years. He built it in 42 days. On the morning of April 14th, 1973, Arden Briggs drove his truck to the edge of Skunk Creek and found nothing where a bridge used to be. Not a damaged bridge, not a weakened bridge, nothing. The flood that had come through Ringgold County the night before had taken the entire structure. The white oak pilings his grandfather had sunk into the creek bed in 1941, the plank deck his father had helped replace, twice the guardrails he himself had repainted the summer his oldest boy turned 12. All of it was gone. The creek was still running brown and high and fast, carrying whatever it had not yet finished carrying, and on the far bank the gravel road simply continued west, as though nothing had happened, as though the gap between where Arden stood and where the road resumed was a minor inconvenience, rather than the end of everything. He stood at the edge for a long time, not because he was in shock exactly. Arden Briggs was not a man who went into shock easily. He stood there because he was looking at the problem the way he always looked at problems, from every angle without rushing to the first conclusion that presented itself. The creek was 42 feet across at this point. The water was still too high and too fast to ford with any vehicle. The concrete footings his grandfather had poured in 1941 were still in place on both banks, 4 squat columns of old concrete, 2 on each side, anchored into the creek bank below the water line. He noted that. He noted the distance. He noted the height of the banks and the speed of the current and the way the debris in the water was moving. Then he got back in his truck and drove the long way around. 22 miles of gravel road to reach a place that had been 300 yards away on the other side of the creek. 22 miles because that was the only other way north to the state highway, and then west, and then south again on roads that turned to mud in wet weather, and to washboard ruts in dry spells, and to choking dust in the heat of summer. 22 miles each way. 44 miles round trip every time he needed a gallon of milk or a bag of feed or a part for a broken machine. Every time his cattle needed a veterinarian. Every time his grain needed to go to the elevator in Mount Air. Every time. He drove those 22 miles to the Ringgold County Courthouse in Mount Air and walked into the Board of Supervisors meeting that was already in session. He was still wearing his work jacket. There was mud on his boots from standing at the creek. He did not sit down. The 3 supervisors looked up when he came in. Lester Crane, the county engineer, was at the front of the room with a folder open on the table in front of him. Lester was 53 years old, a civil engineering degree from Iowa State, 21 years as the county engineer for Ringgold County. He had the bearing of a man who had spent 2 decades making decisions about infrastructure and had learned to carry the weight of those decisions with a particular kind of practiced calm. He looked at Arden without particular urgency. Bud Hamlin, the board chairman, leaned forward slightly. Bud had known Arden since grade school. He farmed 400 acres on the north end of the county and had the kind of face that showed everything it was thinking whether it wanted to or not. He looked at Arden, and something in his expression acknowledged what was coming before Arden said a word. "Morning," Arden said. "The bridge on G61 at Skunk Creek is gone. Flood took it last night." The supervisors nodded. They had heard about the flooding. Several county roads were damaged. 3 other bridges had been impacted, though none had been completely destroyed. "When can you rebuild it?" Arden asked. Lester Crane opened his folder and consulted a list. It was his project queue, every bridge and road and culvert in the county that needed work, ranked by priority and constrained by a budget that was never large enough for a county with 700 miles of roads and 112 bridges to maintain. The G61 bridge serves one property, Lester said, reading from his notes. Single-lane timber construction. Estimated replacement cost $45,000 for a concrete and steel structure meeting current standards. Based on our current project queue and available funding, he paused, running his finger down the list. 5 years. If we are lucky. 5 years, Arden said. We have bridges serving 20, 30, 50 properties ahead of you in the queue. I understand it is an inconvenience, but inconvenience. Arden's voice was flat, not loud. Flat. Dale, my cattle need feed. My grain needs to get to the elevator. My kids need to get to school. I cannot drive 22 miles of gravel every time I need something. 5 years is not an inconvenience. 5 years is a death sentence for my operation. The room was quiet. The supervisors looked at Lester. Lester looked at his folder. I am sorry, Arden, Lester said. I do not have the money or the manpower to move you up the list. I wish I did. Arden stood there for a long moment. He looked at the folder. He looked at Lester. He looked at Bud Hamlin, who had stopped meeting his eyes and was looking at the table instead. Then he said 4 words. I will build it myself. Lester Crane looked up from his folder for the first time since the conversation began. The 2 supervisors on either side of Bud exchanged a glance. Bud himself looked at Arden with an expression that mixed surprise with something that might have been the very early edge of hope. Lester's response was immediate and professional, and delivered with the particular certainty of a man who has a degree on his wall and 21 years of experience behind his belt. Glenn, he said, you cannot build a bridge. A bridge is a structure that requires engineering design, load calculations, soil analysis, material specifications, and compliance with state and federal standards. You cannot just weld some steel together and call it a bridge. Why not? Arden said. Because it would not be safe. Because it would not be legal. Because the county would be liable if it collapsed. Because you are a farmer, not an engineer. Arden looked at him for a moment. My grandfather built the bridge that just washed out, he said. In 1941 with white oak pilings and a crosscut saw. No engineering degree, no load calculations, no state standards. That bridge lasted 32 years and carried every piece of equipment I own across it. The only thing that killed it was a 100-year flood. Lester said, that was a different era. That was a man who needed to cross a creek and did not have 5 years to wait, Arden said. The room was very quiet. I am not asking for permission, Arden said. I am telling you what I am going to do. The bridge is on a county road, but the creek bank on both sides is my property. I will build on my land, I will connect to the road, and when I am done you can come inspect it. If it does not meet your standards, I will take it down, but I am not waiting 5 years. He walked out. The supervisors looked at Lester. Lester looked at his folder and said nothing for a long moment. Then he closed the folder. Now let me tell you about Arden Briggs, because you need to understand what kind of man decides to build a bridge by himself before you can understand what happened next. Arden was 45 years old in the spring of 1973 and had farmed the 280 acres on Skunk Creek since 1952 when his father retired and moved to town. He had been 24 when he took over, just back from 2 years in the Army, just married to Ruth Calloway from the next township, and possessed of the specific confidence that comes from being young and strong and certain that any problem can be solved with enough time and enough effort and enough welding rod. Because Arden Briggs could weld, that was the thing about him that his neighbors understood and Lester Crane did not. His father had taught him to arc weld at 14 in the equipment shed behind the barn on cold winter afternoons when the field work was done and there was time to learn things. The Army had done the rest. 2 years of service had taught him MIG welding and TIG welding and oxyacetylene cutting, and by the time he came home to the farm he could join two pieces of metal the way a surgeon joins two pieces of tissue, cleanly and precisely and permanently. Over 21 years of farming, Arden had welded everything. Broken plow frames that International Harvester said could not be repaired, cracked loader buckets, split axle housings that the dealer wanted to replace at 4 times the cost, hay rack supports and cattle gates and feed bunks and grain bin doors. His barn was a museum of repair work, and if you looked carefully at the machinery in his shed and the equipment hanging on his walls, you could see the distinctive blue-gray beads of arc welds everywhere, each one holding something together that would otherwise be in a scrap pile. His neighbors had a saying about it. If Arden cannot fix it with a welder, it is not broke, it is dead. But building a bridge was not fixing a plow frame. A bridge had to carry weight. Loaded grain trucks, cattle trailers, his combine on a lowboy during harvest. It had to span 42 feet of creek without support in the middle because Skunk Creek flooded every spring, and anything in the channel would get ripped out the same way the old bridge had been ripped out. It had to last not a season but decades. Arden spent 3 days after the supervisors' meeting doing something that Lester Crane would not have expected and could not have imagined. He did research. He drove to the Iowa State University Library in Ames, 120 miles each way, and spent a full day reading. He was not looking for theory. He was not interested in the advanced structural engineering textbooks that lined the shelves in their rows of serious colored spines. He was looking for something specific and practical. Something written not for professors but for men who had to solve problems in the field with whatever materials were available. He found it. Army Corps of Engineers Field Manual Expedient Military Bridge Construction 1958, a guide written for combat engineers who needed to build bridges fast in the field under conditions that did not allow for blueprints or permits or 5-year waiting lists. The manual had tables showing beam dimensions for different spans and different load requirements. It had footing specifications for different soil types. It had sections on improvised construction methods, on making do with non-standard materials, on building structures that were not beautiful but were functional and were safe. And it had a section that Arden read 3 times slowly with his finger tracking every line. The section was about using salvaged railroad rail as structural beams. Railroad rail. The heavy steel sections used on mainline tracks shaped in cross-section like an upside-down capital T with a flat base and a vertical web and a rounded head. The shape was, as the manual pointed out in its matter-of-fact military prose, essentially identical to the I-beam shape that structural engineers considered the most efficient cross-section in existence for carrying loads over a span. A standard mainline railroad rail weighed about 132 pounds per yard and was rated to carry the weight of locomotives. One rail could carry far more than any farm truck that would ever cross a bridge in Ringgold County, Iowa. Arden already knew where to find railroad rail. The Rock Island Railroad had pulled up a branch line in Ringgold County in 1968, 5 miles of track that had run from the main line to an abandoned grain elevator south of Kellerton. The rails were still out there, stacked in rows alongside the old right-of-way rusting quietly in the grass, owned by a salvage company in Des Moines that had been meaning to haul them away for 5 years and had not gotten around to it. He called the salvage company from a payphone outside the library. "You want to buy old rail," the man on the other end said. "I want to buy 20 sections, 30 feet each," Arden said. "What for?" "Building a bridge." There was silence on the line. Then the man said, $15 a section. 300 for the lot. You haul. $300 for the main structural members of a bridge. Arden drove to the site the next morning with his flatbed truck and started loading. Now let me tell you what happened in the days between that phone call and the morning Arden started work, because this is where the story becomes something more than a man building a bridge. On the evening he came home from loading the rail, Arden sat down at the kitchen table across from Ruth. Ruth Briggs was a woman who had married a farmer, knowing exactly what she was marrying into, and who had spent 23 years demonstrating that her judgment about her own life was as sound as any judgment she had ever made. She was not a woman who startled easily or worried without cause, but she was also not a woman who pretended things were simpler than they were. She looked at her husband across the table. She looked at the library book he had brought home, the Army Field Manual with its government issue cover and its tables of figures. She looked at his hands, which were resting flat on the table in the way they rested when he was thinking hard about something. Then she put her hand over his hand. "Arden," she said, "what if the welds do not hold? What if something goes wrong and somebody gets hurt?" He looked at his hands. 30 years of welding, more or less, counting what his father had taught him and what the army had finished teaching him. He had welded things that other men said could not be welded. He had welded cast iron and high-carbon steel and dissimilar metals that the textbooks said would not bond. He had never had a weld fail on him, not once. But he had also never welded anything that if it failed would send a truck and a driver into a creek. He sat with her question for a long time. The kitchen was quiet. Outside the evening was cooling off, and the fields that stretched away from the house were turning dark at the edges. "Then it'll be my fault," he said, "and I will have to live with that. But Ruth, I am not going to be the man who could not cross his own creek. My grandfather crossed it. My father crossed it. I have crossed it every day of my adult life. I am not going to sit on the wrong side of 42 feet of water and wait 5 years for somebody else to solve a problem that I can solve myself." Ruth looked at him for a moment. She did not argue. She had known Arden Briggs long enough to understand the difference between the things he said because he was angry and the things he said because he had already decided. This was the second kind. She stood up and refilled his coffee cup and set it back down in front of him. That was the end of the discussion about weather. The discussion about how had already been happening in Arden's head for 3 days, and by the time he started work on the morning of April 21st, 1973, 1 week after the flood, the how was largely settled. What remained was the doing. He started with the footings. The old concrete footings from the 1941 bridge were still in place. 4 columns sunk into the creek bank, 2 on each side, still solid after 32 years in the ground and a 100-year flood. He chained his Farmall 560 tractor to each one in turn and pulled. None of them moved. The old concrete had done what old concrete sometimes does when it is mixed right and poured right and given enough time. It had become something close to permanent. He decided to use them. He poured new bearing pads on top of each footing, 12-inch thick caps of reinforced concrete that would distribute the load from the steel beams down into the old columns below. He mixed the concrete himself in a rented mixer, poured it into wooden forms he built from scrap lumber, and let it cure for 10 days. The concrete cost $220. Lester Crane drove past on the second day. He slowed the county truck to a stop on the east bank and looked at what Arden was doing. He looked at the excavated area around the footings, at the forms, at the mixer, at the flatbed truck with its load of railroad rail stacked neatly under a tarp. He sat with his window down for a minute without getting out. Then he said something to whoever was sitting in the passenger seat of the county truck. Arden was too far away to hear the words, but he saw the shape of the sentence, and he saw the other man nod, and he saw Lester's expression, which was not hostile, but was the specific expression of a man watching someone make a predictable mistake, a patient expression, the expression of someone who has already seen how this ends. "He will quit by the end of the week," Lester said. His voice carried across the water more than he intended. "You cannot build a bridge with a farm welder and a library book." Arden heard it. He looked up once briefly. Then he went back to checking the forms on the bearing pad. He did not quit at the end of the week. He did not quit at the end of 2 weeks. He worked mornings before the heat built, and evenings after it broke, and on the days when the weather was cool enough, he worked straight through. Dewey Falk, his neighbor from the section to the south, came over after the first week and did not ask whether help was wanted. He just showed up with work gloves on and started helping position the rail sections using Arden's farmall and a chain hoist to move steel that no two men could have moved by hand. Dewey was 52 years old and had been welding since before Arden, but he was clear about the division of labor. "I can weld a fence post," Dewey said. "Arden welds bridges. There is a difference." The rail sections went onto the bearing pads one at a time, 8 of them in parallel across the 42-foot span resting on the new concrete caps at each end. 8 rails, each one approximately 2 tons of steel laid side by side like the strings of some enormous instrument. And then Arden began to weld. What he built in those 2 weeks of welding was not just 8 rails laid across a gap. It was a grid. Every 4 feet along the length of the main beams he cut sections of rail and welded them perpendicular to the span, tying the parallel beams together into a single rigid structure. The cross pieces connected everything into one piece. When he was done, it was not 8 rails. It was one thing. The welding was done in every position that welding can be done. Flat welds on top of the beams, vertical welds on the sides, overhead welds underneath, lying on his back on the steel in the rain with sparks falling onto his jacket, and his face shield fogging at the edges. The beads he laid were not decorative. They were not made to be admired. They were made to fuse old steel into new structure to penetrate deep enough that the joint would be stronger than the base metal on either side. Let me tell you what happened on the evening of the 3rd week, because this is the part of the story that most tellings leave out, the part that happened after dark, when there was nobody there to see it except the creek. It was a Thursday. The temperature had dropped after sunset and a light rain was falling, the kind of rain that is not heavy enough to stop work, but makes everything cold and slick and unpleasant. Arden had been working later than Ruth thought he would be because there was a section of cross bracing near the center of the span that was giving him trouble. The position was awkward underneath the main beams at the midpoint of the span, requiring him to work from below with the creek running 15 feet down in the dark. He finished the weld and let it cool, and then he did what he always did after a weld he was not completely confident about. He examined it. He brought his flashlight close and looked at the bead from every angle he could see. He felt along the edge of the joint with his finger checking for the slight ridge that indicates incomplete fusion. And he found something he did not like. It was subtle. The weld looked acceptable from most angles, but on the underside at the far edge of the joint there was a section perhaps 2 inches long where the penetration was not what it should be. A place where the bead had lain on top of the metal rather than fusing into it. He lay on his back on the steel beams in the rain and looked at that 2-inch section with his flashlight for a long time. 2 inches, in the context of a weld that was 12 inches long and surrounded by other welds on all sides, 2 inches of incomplete fusion was probably irrelevant. The structure was massively overbuilt. He had 8 beams where 4 would have been sufficient, and cross-bracing at 4-foot intervals where 8 feet would have met any standard. The load paths were redundant several times over. Probably. He lay there in the light rain and thought about the word probably and what it meant in a structure that trucks would be crossing. He thought about the first grain truck that would roll onto this bridge after he declared it done. He thought about the driver of that truck, who would have no way of knowing what was underneath him, no way of knowing that a man had lain here one rainy night and looked at a 2-inch section of weld and made a decision. He climbed back up to the bank and got his welding equipment and went back out to the midpoint of the span. He was out there until 2 in the morning. He ground out the inadequate section and re-welded it and let it cool and examined it again and was satisfied. He packed up his equipment and walked back across the creek on the beam grid and drove up to the house. The kitchen light was on. Ruth was not awake. She had gone to bed. But when Arden came in, he found the coffee pot on the stove with a low flame under it, keeping the coffee warm. She had not known what time he would come in. She had not known if he would come in at all that night or sleep in the truck by the creek the way he sometimes did when a job was at a critical point. But she had left the coffee on. He poured himself a cup and sat at the table in the quiet kitchen and let his hands warm against the sides of the mug. This is what it means to be known by someone. Not the grand gestures, not the moments anyone would notice from the outside. A pot of coffee kept warm in a kitchen at 2 in the morning. The understanding that a man doing the most important thing he has ever done might need something warm when he comes in from the dark. Arden sat there for a while and then he went to bed. He was back at the bridge at 6 the next morning. Now, there is something I want you to understand about what Arden Briggs was building that goes beyond the steel and the welds and the railroad rail. He was building on a concept that had come to him while he was standing at the creek on the morning after the flood, looking at the debris the water had carried downstream. Among the debris he had seen the planks from the old bridge deck, the solid white oak boards his grandfather had laid in 1941 and his father had replaced twice since. The boards were waterlogged and heavy, and the flood had carried them a quarter-mile before they caught in the brush along the bank. He understood why. A solid deck acts like a sail. When floodwater rises to the level of a bridge deck, the current pushes against the entire surface area of the planking. Enough force and the pilings give way, the deck lifts and the whole structure goes downstream. That was what had happened to the 1941 bridge. The flood had risen high enough to get under the deck, and then the pressure of the current against 30 feet of solid oak planking had been more than the white oak pilings could resist. Arden's design addressed this without him having read any engineering principle that covered it, without anyone having told him about hydrodynamic loading or open grid deck design. He addressed it because he had looked at the wreckage and understood what had failed and why. His deck would not be solid planking. The main structure was rail with gaps between each beam. Even when he added the oak deck boards on top for the driving surface, the gaps between the rail beams below would allow water to pass through. A flood that rose to deck level would flow through the structure rather than pushing against it. The force that had destroyed the 1941 bridge would have nothing to push against on Arden's bridge. He had arrived at this principle by observation, not by calculation. By looking at broken wood in the water and asking why the wood was broken. By understanding the failure before designing the replacement. No one had taught him that. No library book had specified it. No field manual had covered the particular hydraulics of a Ringgold County creek in flood. He had figured it out by standing at the edge of the water and thinking clearly about what he was looking at. The oak planking for the deck came from a sawmill in Leon, 2-inch thick boards, 12 inches wide, rough sawn and air-dried, bought for $180. He laid them across the rail grid and bolted them down with carriage bolts through pre-drilled holes. The deck was 14 feet wide, enough for a single vehicle with a foot of clearance on each side. He added guardrails made from sections of the leftover rail bent into gentle curves at the approaches and welded to vertical posts made from steel pipe. He painted everything with 2 coats of rust-inhibiting primer gray, the color of things that are built to work rather than to be admired. The total cost when he added it all up on a piece of paper at the kitchen table was $870, railroad rail $300, concrete for the bearing pads $220, oak planking $180, bolts and welding rod and grinding discs $95, paint $40, rented concrete mixer $35, $870. The county had estimated $45,000. He had built a bridge for less than 2% of what the county said a bridge would cost. He finished on June 2nd, 42 days after he started. He stood on the east bank and looked at what he had built. It was ugly. He had no illusions about that. It was gray primer on railroad rail and rough sawn oak planking and welds that were structurally perfect but not cosmetically finished. It looked like what it was, a bridge a farmer had built in 6 weeks with $300 worth of old railroad track. But it was standing, it was straight, and when he walked out onto it and stood at the midpoint and looked down at the creek, running 15 feet below, and then looked back at the bank where he had started and then forward to the bank where he was going, he felt the structure under his feet, the way you feel a thing that has been made correctly. Solid. Not rigid in the way of something that will break, but rigid in the way of something that has nowhere to go. He drove his Farmall 560 across, about 7,000 pounds. The bridge did not flex. He loaded his grain truck and drove it across. 32,000 pounds. The bridge flexed slightly, a 1/4 inch of deflection at the midpoint of the span, which was exactly what the Army manual said was acceptable for a structure of these dimensions under this load. He drove his cattle trailer across, no issues. Then he called Lester Crane. "Lester," he said when the county engineer picked up, "the bridge on G61 is done. Come and look at it." There was a pause on the line. Then Lester said, "I will be out Thursday morning." Arden said, "I will be here." He hung up the phone and went out to tend to his cattle crossing the bridge, without thinking about it the way you stop thinking about a thing once it has become simply part of how you move through the world. On the east side of Skunk Creek, the county road continued toward Mount Ayr. On the west side, his land stretched away to the tree line, his fields and his barn and his equipment shed and his house with the light on in the kitchen where Ruth was making supper. 42 feet of creek between them, 8 rails, 42 days, $870, and not a single person in Ringgold County, Iowa had believed it could be done. Lester Crane was coming Thursday morning, and Arden Briggs was going to be there when he arrived. Lester Crane arrived on Thursday morning at 8 o'clock, which was exactly when he said he would arrive, because Lester was the kind of man who arrived when he said he would, and left when the job was done, and did not make a production of either. He drove the White County truck down the gravel road on the east side of Skunk Creek and parked on the bank and got out and stood there. He did not say anything for a full minute. Arden was on the west bank, standing beside his farm awl with his arms crossed, watching. He had been there since 6, doing the things that needed doing on a farm in early June, and he had positioned himself on the west side deliberately, so that Lester would have to see the bridge from a distance before he crossed it, so that the first impression would be of the whole structure rather than of any single part of it. The bridge was not pretty. Arden had accepted that from the first day, and he accepted it still. Gray primer on railroad rail, rough sawn oak planking welds that were made to hold rather than to look like they were made to hold. It sat low over the creek, closer to the water than the old timber bridge had been, because Arden had built to the height of the existing concrete footings rather than raising them, and it had the particular look of something built to solve a problem rather than to satisfy an eye. But it was there. It was straight. It was solid in the way that a thing is solid when you look at it, and nothing in your body tells you to distrust it when the geometry is right and the proportions make sense, even if you cannot articulate exactly why. Lester Crane was an engineer. He could articulate why. He stood on the east bank and looked at the bridge with the eyes of a man who had been building and inspecting structures for 21 years. And something in his posture shifted slightly as he stood there, some small adjustment in the set of his shoulders that would have been invisible to most people, but that Arden, watching from the far side, noticed. Lester walked onto the bridge. He walked slowly, not because he was testing the feel of it under his feet, though he was, but because he was looking at everything. He looked at the bearing pads where the rail ends rested on the old concrete footings. He looked at the rail sections themselves, at the surface rust on the original metal, and the clean, bright lines where the grinding had prepared the surfaces for welding. He looked at the cross, bracing the perpendicular sections welded between the main beams every 4 feet. He stopped at the midpoint of the span. He stood there and looked down at the creek, which was running clear, now the spring flood 2 months behind it. Then he crouched down slowly, the way a man crouches when his knees remind him he is past 50, and he looked at the underside of the structure from that angle. Then he got down on his hands and knees. He was wearing his county work clothes, the tan shirt with the Ringgold County engineer patch on the sleeve, and he put those knees and those hands on the oak planking of a bridge that a farmer had built without a permit or a blueprint or a licensed engineer, and he looked at the welds from underneath. He was down there for a long time. Arden waited. When Lester finally stood up, he brushed the oak dust off his knees with both hands slowly, and then he looked across the span at Arden on the west bank. He walked the rest of the way across and stood in front of the man who had built what he was looking at. The two men regarded each other for a moment. "This is not how you build a bridge," Lester said. "And yet here it is," Arden said. Lester looked back at the structure for a moment. "You used railroad rail," he said. "I did." "That is not a standard structural material for bridges. It is an I-beam shape rated for 300,000 pounds per rail. I have 8 of them across a 42-foot span. The Army Corps of Engineers has a manual that says that is sufficient for a 60-ton load. I can show you the page." Lester was quiet. He was looking at the bridge the way a man looks at something that has given him more to think about than he expected. His face was not angry, and it was not dismissive. It was the face of a man doing an honest accounting of what was in front of him. "I cannot approve this as a county structure," Lester said finally. "It does not meet state design standards. There are no stamped engineering drawings. There is no load rating from a licensed engineer." "I did not ask you to approve it as a county structure," Arden said. "I asked you to inspect it. Tell me if it is safe." Lester was quiet for a longer time. He looked at the bridge. He looked at Arden. "Off the record," Lester said. "Off the record. It is overbuilt. Way overbuilt. You have got 3 times the steel you need for a single-lane farm bridge. The welds are solid. The footings are adequate. The deck is properly bolted. If I had to guess, I would say this bridge will carry anything you drive across it, and last 30 years without significant maintenance." He paused. "On the record, I cannot approve it." That is all I needed to hear, Arden said. Lester drove back to Mount Ayr and wrote up his inspection report that afternoon. The official finding was that the Skunk Creek crossing on County Road G61 was a private structure on private land adjacent to a county right-of-way, and that the county neither approved nor disapproved its use. It was the bureaucratic equivalent of looking the other way, not an endorsement and not a condemnation, and it was the most Lester Crane could give without risking the county's liability and his own professional standing. Arden read the report when it arrived in the mail. He folded it and put it in the same kitchen drawer where he had put the county's warning letter. Then he drove across his bridge to the grain elevator in Mount Ayr and delivered a load of corn that had been sitting in his bin for 2 months waiting for a way across the creek. The elevator manager looked at his truck when he pulled in. "You found a way across," the manager said. "Built one," Arden said. The manager looked at him for a moment. Then he said, "I heard something about that. Word travels in farm country the way water travels in flat land along whatever channels are available, finding the path of least resistance, moving faster than you expect." By the end of June, everyone in Ringgold County who paid attention to such things knew that Arden Briggs had built a bridge across Skunk Creek with railroad rail and a welding torch while the county engineer said it could not be done. The story had the particular quality of stories that stick the specific numbers 42 days and $870. The contrast with the county's estimate, the image of a man on his hands and knees in the rain welding overhead, in a position that made your back ache just to hear about it. Some people thought it was admirable, some thought it was foolish. A few thought it was both and said so. Lester Crane did not say anything publicly. He filed his report and moved on to the next item in his project queue, and did not mention the G61 bridge in the board meetings that followed except when the supervisors asked him directly, in which case he said what his report said, that it was a private structure and not a county matter. What Arden heard indirectly through the particular channel of a neighbor who had been at the co-op on a Tuesday morning was that Lester had told someone that Arden's bridge would probably not last a full winter, that the freeze and thaw cycles in Iowa would work on the old rail steel and the concrete footings and the oak planking in ways that an improperly engineered structure could not withstand. Arden heard this and said nothing. He went home and checked the bridge and found nothing that concerned him and went back to farming. Now let me tell you about the 5 months between June and November of 1973 because those months are important not for what happened but for what almost happened and did not. The summer of 1973 was dry, not catastrophically dry, but dry enough that the creek dropped to its lowest level of the year by August, a trickle of clear water running over the gravel bed with the high banks exposed on both sides. In those conditions, the bridge looked enormous, a massive steel structure spanning a creek that a careful man could almost have stepped across in 2 strides. The proportions seemed absurd, 8 tons of railroad rail above 8 inches of summer water. Arden crossed it every day. He did not think about it. That was what it meant for something to be working, that it became invisible, that it stopped being a thing you thought about, and became simply a part of the route between where you were and where you were going. He planted his fall cover crop in September. He harvested his remaining corn in October. He kept his cattle on fall pasture as long as the grass held and then moved them to the winter lot and began feeding hay. Normal farm work in a normal fall, all of it done without a 22-mile detour, all of it done through a bridge that cost $870 in 42 days. And then in the first week of November, the rain started. It rained for 4 days straight, a slow, cold, persistent rain of the kind that Iowa gets in late fall when the weather systems stack up and cannot move through. The creek came up gradually at first and then less gradually, and by the morning of the 5th day, Skunk Creek was running higher than it had been since the flood in April. Arden was at the bridge at first light, standing on the east bank watching the water. The creek was carrying debris. Branches and corn stalks and dead grass ripped from the banks upstream, all of it moving fast in the brown current. The water had risen to within 2 feet of the bottom of the bridge deck, higher than the clearance on the old timber bridge had been. Under the old bridge, in a flood like this, the water would have been pushing against the solid oak planking of the deck, hundreds of square feet of flat surface acting as a wall against the current. Under Arden's bridge, the water went through. He watched it happen. The current rose to the level of the rail beams and pushed between them through the gaps, carrying its debris through the open grid of the structure rather than against a solid face. There was pressure. He could see that the water backed up slightly on the upstream side of the bridge, but it was nothing like the pressure that builds against a solid structure in a flood. The force that had ripped the 1941 bridge out of its pilings had nowhere to apply itself here. The bridge did not move. He stood there and watched for 2 hours. The creek crested and then began to fall slowly, the way it falls after a slow rain stops. The debris moved through. The bridge stood. When the water dropped back below the rail beams, he walked out onto the deck and looked at everything he could see. The bearing pads were undisturbed. The welds showed no movement. The deck planks were still bolted flat. He drove across it with his truck, and the bridge felt exactly the same as it had in June. He went home for breakfast. Ruth asked him how the bridge was. "Fine," he said. She put his plate in front of him and did not say anything else because she had known the answer before she asked. And she had asked because it was the right thing to ask, not because she needed to be told. Have you ever watched something you built survive the first serious test? Have you ever stood beside a thing you made with your own hands, and watched the world try it and seen it hold. There is a specific quality to that experience that has nothing to do with pride exactly, though pride is part of it. It is something quieter than pride, a confirmation. The knowledge that the calculation was right, that the judgment that seemed so clear to you while everyone around you was expressing doubt was in fact correct. Not lucky. Correct. Arden had known the bridge would hold. He had known it mathematically from the tables in the army manual, and he had known it from the welds he had examined in the dark with a flashlight before he ground them out and redid them. And he had known it from 30 years of understanding what welded steel does and does not do under load. But knowing and confirming are different things. And on that November morning, standing on the east bank of Skunk Creek while the flood moved through his bridge and the bridge stood still, Arden Briggs received a confirmation he went back to farming. The winter of 1973 and 1974 tested the bridge in the way that Iowa winters test everything. Freeze and thaw cycles worked on the oak deck planking and on the concrete bearing pads and on the old rail steel. Snow and ice loaded the deck and then melted and refroze in the joints. The temperature went from 10 below to 50 above and back to 10 below again through February, which is what Iowa temperature does, and why Iowa winters are harder on structures than colder climates that at least stay cold consistently. Arden inspected the bridge in March of 1974 when the frost came out of the ground and the conditions had finished doing whatever they were going to do. He brought a pry bar and a flashlight and a small hammer, and he went over every joint he could reach. He tapped on the welds with the hammer and listened to the sound, a test that an engineer would not consider rigorous, but that a man who has spent 30 years with metal can use to detect problems that visual inspection misses. He found 2 deck planks that had developed small splits along the grain from the freeze and thaw cycle. He noted their location and replaced them the following week with new planks from the same sawmill in Leon. Cost $11 for the lumber and an afternoon of work. Everything else was unchanged. He reported this finding to no one because there was nothing to report. The structure had done what structures are supposed to do in their first winter. It had held. The years that followed have a rhythm to them that is important to understand. Not because each year brought a dramatic event, but because the absence of drama was itself the point. The bridge worked. Every day it worked was a day that someone did not have to drive 22 miles of gravel. Every grain truck that crossed it in harvest season was a load delivered without delay. Every time a veterinarian needed to get to the west side of the creek, the bridge was there. Every school morning when the bus turned around in Arden's driveway, the children who got on that bus had been driven across the bridge to the east bank from the farm on the west side. The bridge worked, and working was what it was supposed to do, and that was all. In the spring of 1978, 5 years after the flood that took the original bridge, Skunk Creek flooded again. This time the water came up faster, driven by a combination of heavy rain and snowmelt from a late winter storm, and it came up higher. By the morning of the peak, the water was within 8 inches of the bridge deck, higher than November of 1973, higher than any level Arden had seen in the 5 years since he built the structure. He was at the bridge before dawn. The debris was worse than 1973. A section of fence from somewhere upstream had come loose and was riding the current, and it caught on the upstream side of the rail grid and began to accumulate other debris around it. Within an hour there was a tangle of wire and branches and dead corn stalks building up against the bridge on the upstream face. Arden understood the danger, not to the bridge itself which could handle the hydraulic pressure, but to the clearance above it. If enough debris accumulated to form something like a dam, the water level upstream of the bridge would rise faster than the creek itself, and if that rise was fast enough, the deck could be overtopped, which would compromise the oak planking and potentially damage the bearing pads. He drove his farmall down to the bank, hooked a chain to the largest piece of the debris tangle, and pulled it free. It took 3 attempts because the current kept pushing the debris back against the bridge between his pulls. He was in the water twice, knee-deep in April in Iowa, pulling fence wire by hand while the current tried to take him with it. He cleared the debris before it could accumulate enough to cause a problem. The creek crested that afternoon and began to fall. The bridge was undamaged. He replaced 6 deck planks that had been damaged not by the flood, but by the weight of the tractor work on the bank approaches, where the soil had softened from the water, and the heavy tires had rutted the road surface in ways that put uneven loads on the end sections of the deck. He got the planks from the same sawmill. They still had the same grade of oak, cost $22. In the summer of 1981, 8 years after construction, Arden repainted the entire bridge. The original primer had held well better than he had expected, but 8 Iowa winters had worked on it in the places where the paint had thinned over the rough welds and the edges of the cut rail sections. Surface rust had developed in those spots, the reddish-brown patina that forms on steel when the protective coating breaks down. He wire-brushed every surface he could reach and applied 2 new coats of primer. The welds themselves showed no corrosion beneath the paint when he cleaned them. The fusion zone where the new metal had been joined to the old was as sound as the day he had made it. 8 years of weather and load and freeze and thaw, and the joints were unchanged. He painted for 3 days. Cost $40 for the paint and a long weekend of work. In the fall of that same year, Lester Crane retired. He had been the county engineer for 29 years, and his retirement was marked by a small ceremony at the courthouse in Mount Ayr and a write-up in the local paper that listed his accomplishments: the roads improved, the bridges built, the culverts replaced, the budget managed through lean years and slightly less lean years. The write-up mentioned several specific projects by name. It did not mention the Skunk Creek Bridge on G61. Arden read the article at the kitchen table on a Thursday morning and then folded the paper and put it aside. He did not have a strong feeling about the omission. The bridge had never been a county project and had never been in Lester's project queue, so its exclusion from a list of county accomplishments was not an oversight, but a category question. What Lester had built and what Arden had built were 2 different kinds of things. But he thought about Lester sitting at the table with his coffee cooling beside the folded paper. He thought about the man who had said it could not be done, and who had come out on a Thursday morning in June of 1973 and gotten down on his hands and knees in his county work shirt to look at the welds from underneath. He thought about what Lester had said off the record, that it was overbuilt, that he would drive his family across it, and then what he had said on the record, that he could not approve it. He thought about the difference between those 2 sentences, and what it must be like to live inside that difference for 29 years. A new engineer came to the county in 1982. His name was Tom Pratt, and he was 31 years old with a master's degree from Iowa State and the particular combination of confidence and uncertainty that comes from being well educated and newly tested. The supervisors told him early in his first month to take a look at a farmer bridge on G61 when he got a chance. They told him the history, the short version, the bridge that washed out, and the farmer who built his own, and the engineer who inspected it, but could not approve it. Tom Pratt drove out to Skunk Creek on a morning in October of 1984, 11 years after Arden built the bridge, expecting to find what he had been told to expect, a structure that was functional but marginal, something held together by stubbornness and luck that would need to be replaced before too long. He brought a portable deflection gauge, a device that measured structural movement under load accurate to 1/100th of an inch. He brought a loaded county truck 36,000 pounds, and he drove it across the bridge while his assistant operated the gauge from the bank. The midspan deflection under 36,000 pounds was 1/16th of an inch. Tom stood beside the gauge, reading for a moment, and asked his assistant to check the measurement again. His assistant checked it again and got the same number, 1/16th of an inch. For a 42-foot span carrying 36,000 pounds, the acceptable deflection under the current standard was 1/4 of an inch. The standard that had been developed by engineers with instruments and calculations and decades of research on structural behavior under load said that 1/4 of an inch was acceptable for this application. Arden's bridge, built without engineering drawings or load calculations or any instrument more sophisticated than a flashlight and a hammer, was 4 times stiffer than the standard required. Tom Pratt got down on his hands and knees under the bridge, the same position Lester Crane had taken 11 years earlier, and looked at the welds. He brought his own flashlight, and he looked at every joint. He could see the longitudinal welds along the main beams, the perpendicular welds on the cross, bracing, the connection welds at the bearing pads. He was down there for 20 minutes. When he stood up, there was oak dust on his knees and a specific expression on his face that his assistant had not seen before on the face of the new county engineer. He drove back to Mount Ayr and wrote a memo to the Board of Supervisors. The memo was 3 paragraphs long, which was concise for a document of its kind, and it said the following: the Skunk Creek crossing on G61 is the most overbuilt structure in Ringgold County. It is structurally superior to at least 12 county-owned bridges that were professionally engineered and built with county funds. The deflection under a standard load test is 1/4 of the allowable maximum. The welds are sound. The footings are stable. I recommend the county formally accept this structure as a county bridge and assume maintenance responsibility. The Board of Supervisors read the memo at their next meeting. Bud Hamlin, who had been chairman since 1973 and who had been in the room on the morning Arden Briggs walked in with mud on his boots and said he would build it himself, looked at the memo for a long time. Then he looked at the other 2 supervisors. They voted in January of 1985 to formally accept the G61 Skunk Creek Bridge as a county structure. It had taken 12 years. Arden Briggs attended that meeting. He drove across his bridge to get there the same way he had driven across it to get to every meeting and every errand and every delivery for 12 years. He sat in the back of the room in the same work jacket he had worn to the meeting in April of 1973, the one with the worn elbows and the particular crease across the left chest pocket where he had folded it the same way for decades. When the vote was unanimous, Bud Hamlin looked up from the table and found Arden at the back of the room. He held his gaze for a moment and gave a single nod. The kind of nod that contains a sentence without using any words. Arden nodded back. That was the extent of it. No speech, no ceremony, No acknowledgment from the floor beyond the exchange between two men who had been in the same room 12 years earlier on a morning when the stakes were clear and the outcome was not. The county had said 5 years. Arden had said 42 days. The county had eventually caught up to what Arden already knew. A nod was sufficient. He drove home across the bridge and went back to farming. The cattle needed feeding. The equipment shed needed a repair he had been postponing. There was always something. But there is something I want to tell you about, something that happened before that January vote, something that happened in the summer of 1983 that I have been holding back because it belongs here in the second part of this story. In the years between the building and the official recognition, when the bridge was standing but still without the county's blessing and without anyone in an official capacity willing to say publicly what Tom Pratt had written in his memo. In the summer of 1983, Lester Crane drove out to Skunk Creek. He had been retired for about a year. He was living in a house in Mount Ayer with his wife, doing what retired engineers do, reading technical journals, attending the occasional conference, telling younger engineers things they already knew. He was 59 years old, and he looked it a little heavier than he had been as county engineer, a little slower in the way he moved, but with the same precise attention in his eyes. He parked on the east bank and got out of his personal car, not the county truck he had driven 11 years earlier, and he walked onto the bridge. He walked slowly to the midpoint and stood there. He looked at the welds. He looked at the cross bracing. He stood and felt the structure under his feet, and let his engineer's instinct, the one that had been calibrated by 29 years of inspecting structures that other people had built, tell him what it felt. He stood there for a long time. Then he drove to Arden's farm. Arden was in the equipment shed working on the mowing conditioner with a wrench and a degree of focus that meant he heard the car in the yard but did not look up until the sound of footsteps on the concrete floor gave him a reason to. He looked up and saw Lester Crane standing in the doorway of his shed with his hat in his hand. Dale Arden said. Glenn Lester said. Sir. They had not spoken in 10 years. Not since the morning of the inspection in June of 1973, when Lester had gotten down on his hands and knees and then stood up and said what he could say on the record and what he could only say off it. Lester looked around the shed. The welding equipment was against the far wall, the same machines, the arc welder and the MIG and the oxyacetylene rig that had built the bridge. Tools on the wall above the bench organized in the way that men who use tools organize them by function and frequency of use. The smell of oil and metal and old grease that belongs to equipment sheds everywhere. I came to tell you something, Lester said. I should have said it 10 years ago. Arden set down his wrench and waited. That bridge is good work, Lester said. It is honest work. It is the work of a man who understood what he was building and why he was building it. I could not say that in 1973 because I had a job and a reputation and a degree on my wall that told me a farmer cannot be an engineer. I used those things as reasons not to look clearly at what was in front of me. Arden looked at him. Standards are useful, Lester said. I believe that. I spent my career believing it, and I still believe it. But standards are useful until they become excuses. And in 1973, I used mine as an excuse not to help you when I could have helped you. I could have given you one day, one afternoon, looking at what you were doing, telling you what the manual said about railhead profiles and bearing pad dimensions. I could have done that without compromising anything, and I did not do it because I had already decided that a farmer could not build a bridge, and I let that decision close my eyes. He paused. That was wrong. And I have known it was wrong since the day I drove away from that inspection. Arden was quiet for a moment. He looked at the man in his doorway, the retired engineer with his hat in his hand, and he thought about the 10 years of mornings when he had crossed that bridge on the way to whatever the day required. 10 years of evidence that the calculation had been right and the structure had been sound. You were doing your job, Arden said. I was using my job, Lester said. That is different. Arden considered that. He looked at the welding equipment against the far wall. When you told me I could not build it, he said, I drove home and I decided I was going to build the best bridge in Ringgold County. Not just a bridge that worked. A bridge that would make an engineer shut up. I overbuilt it on purpose. 3 times the steel I needed. 8 rails when 4 would have been sufficient. Cross-bracing every 4 feet when every 8 would have met any standard. He looked at Lester. I wanted it to be so solid that no one, not the county, not the state, not any engineer with a clipboard could look at it and say it was not a bridge. He let that sit for a moment. You told me I could not build it. I built it 3 times stronger than it needed to be. So in a way you are the reason it is overbuilt. And if it is overbuilt, it will last longer. Which means you are part of the reason it will still be standing in 30 years. Lester almost smiled. It was not quite a smile, but it was the face of a man who has received something unexpected and does not quite know where to put it. He left without saying much else. He drove back toward Mount Ayr on the county road that crossed Arden's Bridge. And the following summer, and every summer after that, until he could no longer make the drive, Lester Crane came back to Skunk Creek. Alone, and always in summer when the weather was good. He parked on the east bank and walked the bridge, checking the welds with his eyes, feeling the deflection, or the lack of it under his feet, confirming each year what he had confirmed the year before. He died in the spring of 1994. At the funeral in Mount Ayr, there were other engineers among the pallbearers, men who had worked with Lester over his years as county engineer, men who knew the bridges and the roads he had built, and the standard he had held himself to for 3 decades. Arden Briggs was also a pallbearer. Nobody thought that was strange. The people who knew both men understood without needing it, explained that the relationship between a man who builds something and the man who said it could not be built is its own kind of bond. The bond that forms between a challenge and its answer, between a doubt and its proof. Lester Crane had given Arden Briggs the most useful thing anyone ever gave him. Not help, not approval, not the county's blessing, but a reason to build the best bridge in Ringgold County. You could argue that Lester owed him that much. You could also argue that what Arden owed Lester he paid in full on a summer morning in an equipment shed when a retired engineer came with his hat in his hand and heard the most honest accounting of what his doubt had cost and what it had in spite of itself produced. That bridge was standing in 1994 when Lester died. It was 21 years old. The welds had not been repaired. The rail beams had not been reinforced. The concrete footings, the original 1941 concrete that Arden had inherited and built on, had not shifted. The bridge was standing and the creek was running underneath it the same way it had run since before anyone now living was born, and the road continued on the west side toward the farm where Arden Briggs had lived and worked for more than 40 years. Some things that people say cannot be done turn out on closer examination to simply be things that the person speaking has not figured out how to do yet. There is a difference between impossible and unattempted, between what the standards say and what the materials can bear, between the certificate on the wall and the knowledge in the hands. Arden Briggs knew that difference. He had known it since the morning he stood at the edge of a 42-foot gap with nothing but a flatbed truck full of railroad rail and a library book from an Army field manual. and the accumulated skill of 30 years of knowing what welded steel does under load. He had known it, and he had acted on it, and the bridge was still there to say he had been right. The years after 1985 had a different quality to them than the years before. Not easier exactly, because farming in Iowa is never easy, and the decades between the mid-80s and the turn of the century brought their own pressures. The farm crisis of the mid-80s that took neighbors. Arden had known his whole life off land. Their families had farmed for generations. The commodity price swings that made planning feel like guesswork. The slow consolidation of everything that had once been small and local into something larger and more distant and less accountable to the particular conditions of any one piece of ground. Those years were not easy. But the bridge was there. Every morning it was there. And there is something about a problem that has been solved completely and permanently that frees up a portion of the mind that was previously occupied by it, even when the solving happened years ago, and the problem has long since stopped feeling urgent. The 22-mile detour existed now only as a memory, a thing that had been true for the weeks between the flood and the completion of the bridge, and that had not been true since. The bridge was simply part of the landscape, part of the route, part of the unremarkable infrastructure of daily life on a farm in Ringgold County. Curtis Briggs grew up crossing that bridge. He was 12 years old in the spring of 1973, when the flood took the original structure, old enough to understand what the loss meant, and young enough to watch his father build the replacement with the particular attention that boys bring to watching their fathers do things that other adults say cannot be done. He had been at the creek on some of those evenings during construction, not helping, not old enough or skilled enough to help with the welding, but present, watching the way the structure took shape from nothing, watching his father position the rail sections and strike the arc and move the torch along the joint in the rhythm that Arden had made so entirely his own over 30 years. He had not thought consciously about what he was absorbing during those evenings. That is not how it works when you are 12. You do not stand at a creek bank and think, I am learning something here that I will carry with me. You stand there because your father is there and the work is interesting, and the smell of the acetylene and the blue-white light of the arc are things that lodge themselves in memory without announcing their intention to do so. What Curtis understood by the time he was an adult was that his father had not built a bridge. He had built an argument, a physical, structural, load-bearing argument that could be driven across, that could carry grain trucks and cattle trailers and the weight of 30 years of daily use, and that answered without words and without needing to say anything directly the claim that a farmer cannot be an engineer. Curtis took over the farm in stages, the way farm transitions work when they work well gradually and in partnership rather than all at once. Arden was in his 60s by the mid-90s and still farming, still capable of most of what the work required, but aware that the work was beginning to require more recovery time than it used to. Curtis was running the day-to-day operations by the time Arden was 70, with Arden still present, still involved, still the person whose judgment on any question about the land or the equipment or the cattle carried the most weight. Arden taught Curtis the way Walt Marsh had taught no one, because Arden was not his own father and did not have his father's silence. Arden talked. He explained things as he did them, not as lectures, but as commentary on ongoing action. the way a man who has thought carefully about his work for 40 years naturally translates that thinking into speech when there is someone beside him who needs to learn it. He taught Curtis about the soil, about what it meant when the ground compacted in certain ways and what it needed to recover, about rotation and organic matter, and the difference between land that is tired and land that is damaged, and land that simply needs rest. He taught him about the equipment, about the sounds that machinery makes when something is beginning to fail, and the sounds that are just machinery being machinery, and about the discipline of maintenance that keeps old equipment running past the point where other men would have replaced it. And he taught him about the bridge. Not the engineering of it, because that was already built and did not need to be rebuilt, but the principle behind it. They stood beside the bridge one afternoon when Curtis was in his late 30s, a fall afternoon with the creek running low and the leaves turning on the cottonwoods along the bank, and Arden said something that Curtis wrote down that evening because he did not want to lose the exact words. When the county said 5 years, Arden said what they meant was, this problem will wait its turn in a system designed for the average, not for the particular. The system is not wrong. The system handles most problems adequately. But your problem is particular. Your creek does not care about the project queue. Your cattle do not care about state design standards. Your grain does not wait. When the system cannot help you in the time you need help, the question is not whether to wait or to complain. The question is what you know how to do. He looked at the bridge. I knew how to weld, he said. That was what I knew. So I built something that required welding. You need to know what you know how to do. And then when the system fails you, you need to be willing to use it. Curtis looked at the bridge too. The rail sections were weathered now, 30-some years of Iowa weather, having given the steel a surface texture that primer could not entirely prevent, though the structural integrity was unaffected. The deck planks had been replaced twice in sections, and once in full, the most recent full replacement done in the early 90s, when the original oak had finally reached the end of its reasonable life. The new planks were the same grade of oak from a different sawmill, the original in Leon having closed sometime in the 80s. Everything else was original. The welds were original. The rail beams were original. The bearing pads Arden had poured in April of 1973 were original, the concrete now more than 30 years old sitting on top of the footings his grandfather had poured in 1941, which made the foundation of the bridge 62 years old and still not shifted. Curtis ran his hand along one of the guardrail sections. The curved rail bent into its gentle approach curve and welded to its pipe post, and felt the solid resistance of it, the refusal to move under his hand. That is the signature of something built without compromise. What you know how to do, he said. That is the whole thing, Arden said. The summer of 1997 produced a moment that entered the informal record of the G61 bridge told afterward at the co-op and the elevator and the diner on Tuesday mornings, the way that particular kinds of stories get told in small county towns where the inventory of genuinely remarkable events is limited and each one is examined thoroughly. The county had acquired a new snowplow the previous winter, a piece of equipment substantially larger and heavier than the plows in the previous fleet, and in July of that summer it was being relocated from one maintenance barn to another along a route that a new dispatcher had plotted without consulting anyone familiar with the load limits of the county roads along the way. The plow was 44 tons, was Arden had designed the bridge for a 60-ton load based on the tables in the Army Field Manual, which specified the structural capacity of 8 rails of the Rock Island mainline specification across a 42-foot span on adequate bearing pads. He had never discussed this design capacity with anyone except Ruth at the kitchen table on the evening he came home from the Iowa State Library, when he had laid out the calculations on a piece of paper, and she had looked at them and said 60 tons sounds like more than enough. The plow driver had been told the bridge was a county structure rated and accepted. He did not know its history. He did not know that its design capacity had been determined by a farmer with a library book rather than by an engineer with a computer. He drove 44 tons of county snowplow across Arden's Bridge on a Tuesday afternoon in July without slowing down. The bridge deflected 3/8 of an inch at mid-span. The allowable deflection for a bridge rated at its design capacity would have been somewhat more than that, and the bridge had been designed for 60 tons, which meant the plow was operating well within the structural envelope even at 44 tons. 3/8 of an inch was within parameters. Curtis was in the field when it happened and did not see it. He heard about it that evening from a neighbor who had been driving past and had pulled over to watch because a 44-ton snowplow crossing a bridge that most people in the county had understood to be a modest farm crossing was the kind of thing you stopped to observe. He told Arden at supper. Arden looked at his plate for a moment. 3/8, he said. That is what Walt said. He watched the whole thing. Arden nodded slowly. That is within the envelope, he said. He went back to his supper. But later that evening, when the dishes were done and Curtis had gone home and Ruth was reading in the front room, Arden drove down to the bridge in the dark and parked on the bank and sat for a while with the headlights off. He could hear the creek lower in the summer running over the gravel bed with the particular sound that moving water makes in the dark when you are sitting still enough to hear it. He thought about a man in a library in Ames in April of 1973, sitting with an Army Field Manual and working through the beam capacity tables with a pencil, converting railroad rail specifications into load ratings, checking the arithmetic twice because he was a careful man and because the stakes required care. He thought about the number he had arrived at 60 tons and the margin it represented above anything he expected to cross the bridge, because he was a careful man and careful men build in margin. He thought about 44 tons of snowplow crossing that margin with 3/8 of an inch of deflection. Then he drove back up to the house. The next morning he inspected the bridge with the same hammer and flashlight and pry bar he had been using since 1974. He checked every weld he could reach. He looked at the bearing pads. He walked the deck and noted the condition of the planks. Everything was within normal parameters. He put the tools back in the truck and drove across the bridge to start his day. Now let me tell you about the summer of 2008, because the summer of 2008 is where this story arrives at something that was always coming, the moment when the argument Arden Briggs had been making since April of 1973 received its most complete confirmation. Not from a retirement ceremony or a county resolution or a memo from a new engineer with a deflection gauge, from a flood. Ringgold County was hit in June of 2008 by rainfall that set records going back to the establishment of the county weather station in 1901. 6 inches in 4 hours on a Saturday, followed by 4 more inches on Sunday. The creeks and rivers across the county rose to levels that the older residents could not remember seeing in their lifetimes, and the younger residents had no frame of reference for it all. 11 bridges in Ringgold County were damaged or destroyed in the floods of June 2008. 11 structures that had been designed by licensed engineers, built with county and state funds, constructed to current standards, and inspected on the maintenance schedules that the county engineering department maintained. 11 bridges that represented decades of professional engineering practice and substantial public investment. 11 bridges. The damage ranged from deck failure on smaller crossings to complete structural loss on 3 of the larger spans where the flood had undermined the foundations or overwhelmed the load capacity of the structures in ways that no one had adequately anticipated. The county engineering department, now on its fourth engineer since Lester Crane, spent the weeks following the flood in a state of controlled emergency, prioritizing the crossings by impact and beginning the process of cost estimation and contractor solicitation that a county faces when a significant portion of its bridge inventory requires replacement simultaneously. On Skunk Creek, the water rose to within 4 inches of the bridge deck, 4 inches, higher than 1978, higher than any level the bridge had experienced in its 35-year existence. Curtis was there from before dawn, parked on the east bank watching. He had sandbags on hand, though sandbags would have been useless against a creek at this level, and a chain and his tractor and the knowledge that there was nothing structural he could do to help or harm what was about to happen. The bridge would either hold or it would not. And that outcome had been determined 35 years earlier by the decisions made during 42 days of construction, by the depth of the welds and the spacing of the cross bracing and the open grid design that allowed water to move through rather than push against. The water rose to 4 inches below the deck and held there for 6 hours. During those 6 hours, debris came through on the current branches and fence sections and the various material that a creek in major flood carries from the land around it. Some of it caught briefly on the upstream face of the bridge and then broke free and passed through. Curtis cleared the larger accumulations with the tractor chain the way Arden had cleared debris in 1978, standing in cold water to his knees, pulling fence wire off the rail grid with his hands. The bridge did not move. At 2 in the afternoon, the creek began to fall. Slowly at first, then more quickly as the upstream rain moved through and the runoff began to diminish. By evening the water was below the rail beams, and the structure was visible in its entirety from the bank. The gray primer on railroad rail, the deck planking the guardrails bent from Rock Island mainline steel, everything exactly where it had been when the flood arrived. Curtis walked the deck that evening. He brought the same flashlight and hammer his father had used, tools he had inherited along with the farm and the bridge, in the habit of checking everything carefully after a flood. He tapped on the welds and listened. He looked at the bearing pads. He checked the deck planks. He found one plank with a new crack along the grain stress from the debris impact on the upstream guardrail transferring through the deck framing. He noted the location. Everything else was unchanged. He called the county engineering office the following morning to report that the G61 crossing was intact and passable. The engineer, a man named Garrett, who had been in the position for 3 years, said something that Curtis thought about for a long time afterward. "That bridge is the least of my worries," Garrett said. "I have 11 of my own that need rebuilding." Curtis asked how long it would take. 5 years, Garrett said. "If we are lucky." Curtis held the phone for a moment after that. Then he said, "I understand. Let me know if there is anything the county needs from me on the G61 crossing." He hung up and stood at the kitchen window looking out at the field that sloped down toward the creek, at the glint of the water still running high and brown in the distance, at the structure that spanned it 35 years old and undamaged, while 11 county bridges waited in a queue. 5 years, if we are lucky. He thought about his father standing in that same room in April of 1973 after the supervisor's meeting with the Army field manual on the table and a piece of paper with calculations on it. He thought about the 4 words that had changed everything. He thought about 42 days and $870, and the particular way that a problem looks when you decide to solve it yourself rather than wait for someone else to solve it for you. Now let me tell you about Vera Briggs, because this is where the story completes itself in a way that neither Arden nor Curtis could have planned or expected, in a way that the bridge itself seems in retrospect to have been pointing toward all along. Vera was Curtis's daughter, born in 1984, which meant she was 24 years old in the summer of 2008 and had just completed her 3rd year of a civil engineering program at Iowa State University in Ames. Iowa State, the same school where her great-grandfather had no connection, and her grandfather had driven 120 miles to sit in the library for a day with an Army field manual. She had grown up on the farm the way Curtis had grown up on the farm, with the bridge as part of the ordinary landscape of daily life, a thing she crossed without thinking about the way you cross any threshold you have crossed since childhood. She knew the story, the flood and the county meeting and the 42 days and the $870 in the way that family stories are known as a fixed narrative that has been told often enough to have acquired the texture of legend without losing its factual basis. She had not until her 3rd year of engineering school thought about the bridge as an engineering problem. Her structural analysis professor assigned a semester project in the fall of her junior year, a case study in which each student was to identify an existing structure, analyze its design using the principles covered in the course, and evaluate whether the design decisions were appropriate for the intended application and load conditions. The professor suggested bridges as a natural subject given the unit they had just completed on beam theory and load distribution. Vera thought about the G61 crossing on Skunk Creek for approximately 30 seconds before she knew what her case study was going to be. She drove to Ringgold County on a Saturday in October. She brought her structural analysis textbook and a notebook and a measuring tape and a camera and the same flashlight that had been in the farm's equipment inventory since the 1970s, the one with the handle worn smooth from decades of use. She spent 4 hours at the bridge, measuring span and beam dimensions and spacing, documenting the bearing pad geometry, photographing the welds from every accessible angle, recording the deck plank thickness and the guardrail cross-section. She lay on her back under the bridge on the Rocky Creek bank in October in Iowa, with the flashlight in her mouth and the measuring tape in both hands, looking at the underside of a structure her grandfather had built 35 years earlier. And she felt something that she later described to her professor as a combination of admiration and frustration. Admiration for the clarity of the structural logic. Frustration that she had grown up adjacent to this object and had not understood until now what she was looking at. The welds were extraordinary. She had been in the structural lab at Iowa State. She had seen test specimens and load frames and the results of destructive testing on welded joints of various grades. She knew what a good weld looked like and what an inadequate weld looked like and the difference between them. The welds on her grandfather's bridge were by the standard of what she had learned exceptionally good. Deep penetration, consistent bead geometry, no evidence of porosity or cracking in the visible surfaces. the kind of welds that a certified structural welder produces when working carefully on joints that matter. Her grandfather had been certified by nothing except 30 years of practice and the standards he held himself to in the dark with a flashlight. She wrote her case study over 3 weeks. It ran 42 pages, which was considerably longer than the assignment required, and it covered the structural logic of the railroad rail beam system, the hydraulic design principles embedded in the open grid deck, the foundation strategy of using existing footings with new bearing pads, and the long-term performance record, as evidenced by the 2008 flood data she had obtained from the county engineering office. She included the original cost figure and the county's estimate alongside the Tom Pratt deflection test results from 1984. Her professor, a man named Dr. Aldous Fenner, who had 30 years of structural engineering experience and several published papers on rural infrastructure design, read the case study over a weekend and called Vera into his office on the following Monday. He was a deliberate man, Dr. Fenner, the kind of professor who does not offer opinions quickly and does not retract them once offered. He had the measured speech of someone who has learned that what you say in a classroom or an office can lodge in a student's mind for decades and should therefore be said accurately. He looked at Vera across his desk. "Your grandfather built this from railroad rail," he said. "Yes," Vera said, "without engineering drawings." "Without any drawings," she said. "He worked from the Army field manual and his own calculations. And the deflection test in 1984 showed 1/16th of an inch under 36,000 pounds. That is in the county records." Dr. Fenner was quiet for a moment. He looked at the case study on the desk in front of him, at the photographs of the welds and the dimensional drawings Vera had produced from her field measurements. "The hydraulic design," he said. "The open grid allowing water passage. Was that specified in the field manual?" "No," Vera said. "My grandfather figured that out from looking at why the original bridge failed. The solid deck acted as a sail in the flood current. He designed around that without having a name for the principle." Dr. Fenner looked at the photographs again. The principle she was describing had a name in structural hydraulics. It was called hydrodynamic loading mitigation through open deck design, and it was the subject of several research papers published in the 1990s. By engineers working on rural bridge resilience in flood-prone regions. The principle had been formally recognized and codified in the literature roughly 20 years after Arden Briggs had applied it intuitively to a crossing over Skunk Creek in Ringgold County, Iowa. "I would like to see this bridge," Dr. Fenner said. He drove to Ringgold County on a Saturday in November, a long weekend drive from Ames down into the rolling landscape of the southern Iowa counties. Vera rode with him, and Curtis met them at the farm and walked them down to the crossing. Dr. Fenner stood on the bank for a while before he walked out onto the bridge, the way Lester Crane had stood on the bank in June of 1973, taking in the whole structure before examining the parts. He walked the deck slowly. He crouched at the midspan and looked at the bearing pad connection. He went to the bank and looked at the underside from the angle that the bank allowed. He noted the spacing of the cross bracing and the consistency of the weld geometry. He asked Curtis questions about the construction sequence and the tools used and the source of the rail sections, and Curtis answered what he knew and said when he did not know, referring some questions to what Vera had documented and others to the account that Arden himself had given in the conversations Curtis could remember. Dr. Fenner stood on the west bank for a long time looking at the bridge from that angle from the side Arden had stood on when he waited for Lester Crane to finish his inspection in June of 1973. Your grandfather did not need an engineering degree, Dr. Fenner said finally. He needed a creek to cross and a welder to cross it with. Sometimes that is enough. Sometimes a man with a welder and a problem will outbuild a department with a budget and a timeline. And sometimes the structure that no engineer would sign off on is the one still standing when the approved ones have washed away. He paused. I want to talk to my department about including this case in our rural infrastructure curriculum, he said. With your permission. Curtis looked at Vera. Vera looked at Dr. Fenner. My grandfather would have had something to say about that, Curtis said. What would he have said? Dr. Fenner asked. Curtis thought about it. He thought about his father at the kitchen table with the coffee cooling beside the folded newspaper, and at the creek bank with the flashlight in the dark, and in the equipment shed with his hands on a mowing conditioner and a retired engineer in the doorway. He would have said, "Do whatever you want with it," Curtis said. That is what he told people when they asked to use something of his. Do whatever you want with it. Vera's senior thesis, completed in the spring of her final year, was titled Rural Bridge Design Using Salvaged Materials, a Case Study in Intuitive Structural Engineering. The opening paragraph read as follows. In 1973, my grandfather built a bridge from railroad rail because the county told him to wait 5 years. He had no engineering degree and no approved drawings and no budget beyond what he could manage from the farm account. He had a welder and a library book and 30 years of knowing what metal does under load. The bridge is still standing. This thesis explores why and what the principles he applied without knowing their formal names can tell us about building infrastructure that lasts in places where conventional systems have failed to help. The thesis was accepted with honors by the Civil Engineering Department at Iowa State University. Dr. Fenner wrote in his evaluation that the thesis demonstrated an unusual integration of empirical field analysis and formal structural theory, and that the subject structure represented a case of what he called intuitive engineering. The application of correct structural principles arrived at through observation and experience rather than formal training, which he argued deserved more serious study as a model for low-cost rural infrastructure development. Vera brought the bound copy of the thesis home to the farm on a Friday afternoon in May, the weekend after her graduation. Curtis was in the barn when she arrived, and she set the thesis on the kitchen table and went to find him. And by the time they came back inside, Ruth, who was 83 that spring and still living in the farmhouse, had found the thesis on the table and was holding it in her lap in the kitchen chair she had sat in since before Vera was born. Ruth held the thesis for a long time without opening it. She held it the way you hold something that is connected to a long chain of things to a kitchen in the spring of 1973, and a man looking at his hands and a pot of coffee kept warm on a low flame until 2 in the morning. Then she set it on the table in the center where the light from the window fell across the cover, and she looked at the title and her granddaughter's name printed below it. She did not say anything for a while. Then she said he would have read every word. The bridge was 35 years old that spring. It was standing. The welds were the same welds that Arden Briggs had laid in April and May of 1973, inspected and confirmed by a man who had gotten down on his hands and knees to look at them and could not approve them officially, but would have driven his family across them, inspected again by a man with a deflection gauge who found them 4 times stiffer than the standard required, examined by a civil engineering professor who recognized in their geometry and penetration the work of someone who understood what he was doing, and looked at by a young woman with a flashlight on a cold creek bank in October, who saw in them what 30 years of practice looks like when it is applied to something that matters. The oak deck planks had been replaced. The paint had been renewed. The guardrail on the upstream side bore a small dent from a piece of fence wire that the 2008 flood had carried into it at speed. These were the marks of use and time and the ordinary violence of weather on a structure that has been in service for more than 3 decades. The rail beams were unchanged, the welds were unchanged, the bearing pads were unchanged. The original 1941 concrete footings that Arden's grandfather had poured 32 years before Arden built his bridge, and that Arden had tested with a tractor chain and found solid, were still in the creek bank, still carrying the load. The county had eventually rebuilt the 11 bridges damaged in the 2008 flood. It had taken longer than 5 years, as these things often do. The estimates and the contracts and the materials and the weather conspiring to stretch every timeline. When the last of the 11 was completed, the county road system had a new inventory of concrete and steel structures engineered and stamped and permitted built to current standards, carrying the expected traffic of Ringgold County roads. The G61 crossing on Skunk Creek was not among the 11 that needed rebuilding. It had carried the 2008 flood within 4 inches of its deck and walked away unchanged. Sometimes the bridge that takes 5 years to approve takes 6 weeks to build. And sometimes the ugly structure, the gray primer and railroad rail and rough sawn oak planking and the welds of a man who learned his trade from his father and the United States Army, is the one still standing when the approved ones have washed away. Arden Briggs knew that. He knew it at 45 years old, standing at the edge of a broken road with a flatbed truck full of old rail and a library book, and the particular certainty of a man who has looked at a problem clearly and understands what it needs. 8 rails, 42 days, $870. He built what the creek required, no more and no less, except for the margin he added, because careful men add margin, the extra steel that became the bridge's signature. The overbuilding. That was the answer to a county engineer's doubt, and that turned out to be the reason the structure was still carrying loads. 35 years later, that its designer had not anticipated when he laid out the rail sections on those concrete bearing pads in the spring of 1973. He is gone now. He farmed until he could not, and then watched his son farm until watching was no longer possible either, and then he was gone the way people go when they have done what they came to do, and the land and the work continue without them the way it was always going to. But the creek is still there, and the bridge is still there. And on the kitchen table of the farmhouse his grandfather built a civil engineering thesis sits in the afternoon light with a young woman's name on the cover and the story of a 42-foot span and 8 rails of Rock Island Railroad steel inside it, because a man in 1973 knew what he knew how to do and was willing to do it, and because the things we build with our hands out of necessity and stubbornness and the accumulated knowledge of a lifetime sometimes outlast everything we might have said about them. The water runs under the bridge the same way it has always run. The rail beams span the gap the same way they have spanned it since the spring after the flood that took the original structure. The welds hold, they were always going to hold. Arden Briggs made sure of that on a rainy night in the 3rd week of construction, lying on his back on steel beams 15 feet above a creek with a flashlight in one hand and the absolute refusal to accept, probably in the place where certainly was required. That was the bridge. That was the man. That was what it cost, and what it came to, $870 and 42 days and 30 years of practice and one night in the dark making sure the work was right before he called it done. The county told him 5 years. He built it in 42 days, and it is still standing.